Hello. Today we're going to solve the most classic physics 2D problem. So something is shot off at a certain velocity at an angle, and we want to find the range. How far does this thing go? So I'm just going to kind of set up the problem first and then kind of go over what we did in the past and then how we're going to use that for our setup. So classic physics problem is, let's say, a cannonball. Let me pick a better color. Okay, so a cannonball is shot out at 10 meters per second with an angle of 30 degrees. Find its range. And what I mean by range is d and the x. All right, so that's the classic physics 2D problem. Now, how do we solve this? Well, in our previous video, we said even though I'm not going to give any numbers, we can actually go pretty far with just substitution with variables. So we know that something shot off an angle, and we're going to call it v theta. There's the angle. It could be broken down into components vi, vc, which are things that we could solve. Using the relationship of sine and cosine, we're able to have v theta sine theta and v theta cosine theta. Now, this projectile, we're going to make one big assumption. So let's say this is our grass or ground, whatnot. And let me do a better job making it horizontal. Get a line. Okay, horizontal. And we have a cannonball that's being shot. So here's our cannon. A ball is going to come out and it's going to land over here. Now, in real life, technically, this is off the ground. But for our problem, we're going to assume one big thing. dy is equal to 0. Can we solve it if dy is not 0? Yes, but at least on my first problem, I want to make it easier. So even though cannonball technically is off the ground, we're going to assume it's going to be at the same place. Its start and finish is the same place. So let's set it up the problem. vi, vf, atd. That's my vertical. I'm going to do my horizontal, which is d vc t. And remember, my goal is to find out how far this thing went, the range. I don't know vc. I know it's v theta cosine theta. I don't know t. I don't know. I do know this. This is negative 9.8. And I just said dy is equal to 0 because that's the setup of this problem. So now we need one more variable to solve for another one. So we're going to use what we do know. So v theta is equal to 10. And we know the angle is 30. So we're going to plug it in as if it was up here. So v theta is 10 times sine of 30. And we're going to do this one over here. This one is 10 cosine of 30. You need a calculator for this. Just to let you know, I typically use a TI 30. You want to make sure you're in degree mode. For this calculator, all you have to push is the DRG, which is degree. And then you get to choose between degree, radians, and I don't even remember what GRD is. If you're using a graphing calculator, if you push mode, you'll see a place where you could select between degree and radians. For my class, degree. For math class, most likely you might be in trig, radians. So be careful as you go back and forth that you don't forget to switch back. But it'll get really obvious because radians, the numbers are all small, and degrees, all the numbers are most likely big. So that kind of is a big, uh-oh, something's wrong, or interesting. Let me make sure my calculator is set up correctly. So we're going to solve it. I purposely picked 30 for a reason, and hopefully you find out really quickly why I picked 30 for a reason, and that's because 30 sine of 30 is 0.5, so this is just 5. I don't have room to write the units, but it's meters per second. Cosine of 30, and it's kind of special, not as much. but it's something that probably most of us know, memorized. And this one is equal to 8.66. Okay, so we have 1, 2, 3. That's technically we have one more thing we know. If this is 5, this is -5. How do we know that? So I'm going to write it over here. Remember, one of the equations is VF squared equals VI squared plus 2AD. If my D is 0, VF squared equals VI squared. So it's equal but opposite. So now we have 1, 2, 3, 4. We're looking for time because time is related to that one. So if we solve for it, the easiest equation to solve for time, in my opinion, is VF equals VI plus AT. VF is -5, VI is 5, plus -9.8 T. So we get 10 divided by 9.8. So the time here is 1.02. So that means this is also 1.02. So 1.02 times 8.66 will give us 8.84 meters. So that would be our answer right there for how far it goes. Interesting, huh? I'd like you to do the same thing, but with 60 and see what kind of answer you get. All right, so let's do it over here and hopefully I have enough room. If not, I apologize. I'm going to do it with 60. So I'm going to kind of cheat and just make it easier for myself. VI equals 10 sine of 60. VF is negative that. A is -9.8. T is what we're looking for. And D is equal to 0. And the reason why we want to know T is because we need it for this side. We're still trying to find this. I'm running out of room, so I'm going to cram it in, but it's going to be 10 cosine of 60. And then we have T. All right, so in trigonometry, 0, 30, 45, 60, 90 are important angles. Cosine of 60, I believe, is a half. So that means VC is equal to 5. Okay. I'm sorry that I wrote down. It just didn't have enough room. Sine of 60 should be 0.886, or sorry, 0.866. So times 10, you get 8.66. So it's pretty much this one, but flipped. All right, let's see. So if that's 8.66, that means this is -8.66, which I kind of write there. Let's solve for time. The easiest equation for time is VF equals VI. Let me choose a different color. Do blue just for Bruins. VF equals VI plus AT. This is kind of just double because this is negative, this is positive, so it'll be negative times 2. 1732. That doesn't seem right. 1732. 1732 equals -9.8 T. So T is equal to, divided by 9.8, 1.77. 1.77 seconds. Multiply that by 5. And you get 8.84 meters. Curious. They're the same. All right. Why?